All right, this is a little bit of an explanation for the YMCA Submax bike test. Since we ran out of time at the end for me to really go over and explain it to you, I wanted to make sure you knew what you're supposed to do, and a couple of you have already tried and are having a little bit of trouble. So the first part that we're going to look at is this. Okay, so this is the graph. Don't worry about filling anything in the test 1, test 2, test 3. Okay, that would have been if we retested her, but we're not doing that. So all you need is her name, okay, Raylene, her age, 30. We're gonna guess that she weighs 125 pounds. That's just made up, but put in 125 pounds there, convert that to kilograms. So her predicted heart rate max, you take 220 minus her age, which is 30, 190. We had her resting heart rate and resting blood pressure, so you're just gonna fill that in. Her resting heart rate, you can see, was 124/76, and her resting, that was her resting blood pressure, and her resting heart rate is 80. And then you'll see this will come into play. Age predicted max was 161.5, but if you pull this one out, you'll have what you need there. Okay, so back to over here, what you want to do is you want to, let me see if I can do this. What you want to do is you need to find the workload. Okay, so plot the heart rate of the two workloads versus the work. Well, now here's the thing. We had 3 workloads, okay? So you only plot the last 2. So in this case, we only ran 3 stages, so the last 2 would be stage 2 and stage 3. If she had gone into the 4th stage, then it would have been stage 3 and stage 4. So you find the workload, which is the same as kilopounds. Okay, so her workload in the 2nd stage was 1.0, and you take the final heart rate. Now, we're going to run into a problem here, just so you know, because her final heart rate in the end of this stage was greater than her final heart rate in the end of this stage. So I want you to still do it anyway. This is one of the limitations of a test like this when you're doing manual heart rates. It's obviously wrong, but just so you know what should happen, you're going to take the 1 kilopound, go up from there, and find 132 beats. Put a little dot there, okay? The next one, you're going to find 1.5 kilopounds, and her final workload was 120 beats per minute, okay? So you would put it there. Then you would take a ruler and simply connect the dots and extend it to the top. Now, because her heart rates were flip-flopped, we're not going to do that because that's going to mess us up. So what we're going to do is we're going to, as long as you know what is supposed to happen right there, we're going to use different workloads, because if you look at this 132 to 100, that doesn't make any sense. We don't increase intensity and all of a sudden see a heart rate drop. Okay, and if you look at these other ones, you would see, yeah, it would increase 108 to 120, and then slowly as she stabilizes, it would, you might expect it to level off or drop a little bit, but spiked up to 132 and then it dropped to 100, that simply doesn't make sense. So what we're gonna do, just to be a little bit sneaky, is we're going to take this heart rate again. So pretend her final heart rate in stage 2 was 112, okay, and then her final heart rate in stage 3 was 120. So you'll go up from 1 kilopound, put it there, go up from 1.5 kilopounds, put it at 120. Then what you need to do is take the line, we already determined her heart rate max, so 220 minus her age, and you're just gonna draw a line straight across, okay? Just take a ruler and draw that line straight across. Then take that same ruler, connect dots 1, dot 2, and you just keep extending the line up until it hits the heart rate max, okay? Until it hits that line. Once it hits that line at 190, you're gonna drop it straight down, and that is going to be her predicted VO2 max. Now, one of the things you need to explain for me is why her predicted heart rate max would be somewhere around 4.0 when we're going to see Natalie's heart rate max was way higher. It's not, Natalie might be more fit because she is a runner, but this is a huge difference. So I need you to explain to me why Raylene's appears to be so low, okay? But that's how you do this one. Okay, now how do you do this one? Okay, so and that's here. You'll plug that in. So estimated max work rate. okay? So look up here, see how this says work rate, kilograms per meter per minute equals workload in kilograms, and remember kilograms and kilopounds can be used interchangeably, times revolutions per minute times 6 meters per revolution. So what this is saying is, how many times does the wheel go around? Okay, well, if you'll look down here, you'll see 50, and you might remember 50 was her cadence. I was trying to keep her right at 50 circles per minute, okay, 50 revolutions per minute. So that is that one. And then 6 meters, I don't know if you remember this from the Wingate test, but since we are on a Monarch bike, we know that every time you pedal, it will propel you a distance of 6 meters. Okay, so we already know these two things. All we need to figure out is what was her workload or her kilopounds. So in stage 1, this one's fixed because everybody gets to stage 1, right? So stage 2 is determined based off her heart rate. So since her heart rate was 108, we looked at the chart in the lab. Here I'll go. We looked at the chart in the lab. Okay, her heart rate was above 100, so that means stage 2 will be at 1.0 kilopounds. That's how we knew that, okay? So we go back here, and we're going to type in 1.0 kilograms times 50 revolutions times 6 meters per revolution equals, okay, and that's literally what you type in here in stage 2. So that will be 300 is what that works out to. Now the way you know it's stage 2 and stage 3, okay, it tells you stage 2 and stage 3. Down here it says stage A and stage B. So again, you want to take the final 2 workloads. Okay, so since she only did 3 stages, the final 2 workloads are stage 2 and stage 3. If she had gotten to the 4th, it would be stage 3 and stage 4. But so what you're going to do, you've already done this up here. So this one is just her estimated max work rate. Okay, so her estimated max work rate is going to be in the final stage because this number is going to be 450 divided by her body weight in kilograms, add 7, and there's her VO2 max, her predicted VO2 max. Okay. Can give her the percentile rank and then classify her. Now method B is a little bit different because you're not using the chart, you're just calculating it, and you need to calculate the slope of the line. Okay, so how do we figure this out? The stage A work rate. We'll look up here, this is the work rate. Okay, so stage A, and this is going to sound confusing, is the first stage of the final rate, or the final 2 rates. You want the first one. So again, she made it to 3 stages, so the final 2 stages, that's 2 and 3. So stage A would be 2, stage B would be 3. Now if she made it to 4 stages, then you would do stage 3 and stage 4. But since she only made it to 3, stage 2, which we calculated already, was at 300. Again, here you go. So you can see this because it was 1.0 kilopounds times 50 times 6 equals 300, okay? So then down here, it's gonna be 1.5 kilopounds, and you put in the rest and you get that. So that will go here. You literally now just plug it in. So stage A goes here, divided by her body weight, and that equals this number, okay? You do the same thing for stage B, which is the second one. You get that number. Now you literally take this number, put it here, take this number, put it here, and heart rate A is her heart rate at the final stage. Okay, so here you go. So we're still in A. This stage 2 is A. So 132 and then 120. Now remember, we're flipping this, and we were gonna use oh shoot, I forgot what we said we were gonna use. I think we said we were gonna use 120. I forget, whatever I said earlier, whatever we thought was reasonable. Okay, but that her heart rate at the end of the stage, just pick a heart rate that you think is reasonable, just make sure it's consistent for the sake of doing this. In reality, you need to know that it didn't work because of this weird number, okay? But, so you're gonna take heart rate A minus heart rate B, that gives you the slope, okay? Then you literally take this number here, plug it in here, you take your slope, plug it in here, you take your heart rate max, which we know from here, okay? So her predicted heart rate max, plug it in there, minus her heart rate from B, so this at the end of the second stage, and that equals her VO2 max. Okay, I hope that helps.